Welcome back, STEM students, to another marvelous Wednesday. Let's go ahead and get started today with looking at the previous homework highs and lows. I personally take responsibility for this one. No corrected lab reports. I know I said that I was going to write comments on it, which I never got around to, so that's my fault. But we're definitely going to work on those before next week because there was some major stuff that needed to be corrected. So I will get to comments hopefully today or tomorrow. Good job on the bridge building for the most part, everyone. Y'all got to level 10. I saw that someone completed level 10, so I went back and I had to go make sure that I could actually do that. But great job for the most part. I haven't seen the worksheets from the last class period. These were the worksheets where you were just kind of attaching the definitions for the words and then also the word math problems. I'm going to assume that y'all turned those into my dad and my brother. So hopefully I can get those from them soon to look over them. All right, so now we're moving on to Unit 2 Science. This is my forte. This is my field. This is what I geek and dig. So y'all are definitely in for a treat here. So what we're going to focus on for this class period and homework and stuff until next class period is pretty much just kind of a general overview of what is science, why do we do science, the different fields of science, and so on and so forth. We'll also look into some methods of conducting researches and surveys and go ahead and do some ourselves so we can get our feet wet a little bit. But there's just so much in science. It's so fascinating that we have to start by defining it. So, introduction to science. What is science? Well, according to a Google definition, because I had to think about this myself because there's just so much to it. So what they gave is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. That's a mouthful, but I like to pick out the words study and observation and experiment. And honestly, the way I would take that to mean is anything that you would like to study, and you can do that through observation experiments, classifies itself as science. Now, I threw in some stereotypical science figures that we see in common day here. We have the mad scientist here on the left, and the genius nerds that probably nobody understands over here on the right. But science is so much more than that. Thinking of science just right now, science is when you start asking questions about the way that something works and you start figuring out how that works and stuff, right? That's the study of science. You're learning something, so you're studying science. You're not exactly contributing to science in the fact that if you're learning about something, but you're definitely being intrigued and engaging in science and stuff. So the fields of science, which are great and many and don't fit on this page, are kind of divided up into three different things here. We have the natural sciences, the social sciences, and formal sciences. And the natural sciences are your classic ones where everyone thinks of science. At the very top of the list, we would put chemistry. Well, I would put chemistry. And then there's physics, earth science, astronomy, and biology. These are the ones that you can, they're more what is it called? They're more natural and they're just physical things that you can experience and stuff, except for physics, which is forces and stuff, but it's observational stuff and analytical stuff. And then you have your social sciences, which usually involve the definition for a social science is that it involves human behavior. So in economics, we have the power of spending, the power of money, and stuff like that. And then we have psychology, right, which is the study of individual people and behavior patterns in a person. And then sociology is kind of like psychology, except that you don't want to look at one person or a few people. You want to look at society as a whole, so a bunch of people all at once. So if you want to figure out trends and kids going to college and stuff. Is it going up? Is it going down? That would be a sociology question. Whereas if you want to look at an individual and the likelihood that he, based on his past and stuff, and going to college, which it's highly unpredictable. Um, you would kind of look at psychology, and then the formal sciences are the ones that set up the other ones, which would be include mathematics and logic, and they're really the basis of all the other sciences because you need mathematics and logics for the other ones. And you might ask yourself, where does mathematics play a role in psychology and sociology? And if I had a whole long semester, I could teach you in depth why they're so fundamental to these. And it's one word, statistics. So when you do conduct a study, especially a survey study, you get a bunch of results, right? And they're not all the same. That's variation in science. And variation is a very important thing because if there wasn't any variation, then it would be all straightforward, and a 2-year-old could get the answers to what is gravity and stuff. And so there's variations of different gravities, right? Like you don't have the same gravity on Earth as in Moon and Jupiter and whatnot. So there's variation in gravity itself. So that plays a very important thing. So the role of statistics is to be able to describe such variations. How true is it that 5-year-olds are 3 feet tall when they're 5-year-olds? And we know for a fact that some 5-year-olds are not 3 feet. Some 5-year-olds are going to be smaller, and some might be bigger. So there's variation with that, and what we can do to describe such variations is use statistics to be able to describe that and see how true is something. It's very fascinating field because you look at trends and you look at how true hypotheses are, and you get to measure how true they are and how much of an impact they have. It's a great math class, and I don't think it's taught very well or very much in high school, and it's kind of sad to me. But if you definitely have a chance to take it, go ahead and take that in college or whatever. Learn about it as you can because there's statistics everywhere, and there's one famous, what's it called, fact. It's like 97, 98% of statistics are made up and whatever. I was like, oh yeah, maybe, but we just got to be careful, right? And check how legit they are and stuff. So why study a science or some particular area of interest, right? Let's just call it a particular area of interest. Why would we study that? So first of all, it would probably be curiosity. You want to figure out how something works. Why does a clock tick when it does? How does the battery provide the chemical power to move gears and stuff like that? So curiosity is a big one. And then if you are interested in helping others, then you would probably say to inform the public about a problem. So we'll get to some examples here in a minute. I've been involved in research and science and stuff. As you probably don't know, or maybe you do know, I studied biochemistry in college, and so there's a lot of science into getting a biochemistry degree, apparently. And a lot of the university where I go to, they do a lot of research. That's what they pride themselves in, is advancing knowledge. And our motto is like, what starts here changes the world and stuff. So they're always starting new stuff, trying to change the world in different ways. And which one time they had a scientific experiment, and I kid you not, this led to a cricket invasion at a football game. I won a UT football game, and there was crickets invading one section of the stadium, and the 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 fans were fleeing that section because of the invasion of crickets. So I told him straightforward, man, hey, look, it's a science experiment gone wrong. I was informing the public, right? And then advanced scientific knowledge to help humanity. It's pretty much the same as helping to inform the public. It's just so there's different studies that you can do, obviously, within science, and one that is it coming up? Okay, we'll save that for later. But yeah, it's helping out humanity, right? A cure for cancer, antibiotics. That was a random discovery, by the way, but it obviously helped people and is very important to modern medicine. Modern medicine. It's actually what kind of funded modern medicine. So the scientific methods, how do we go about studying something? How do we know what we know to study? So we go ahead and ask a question. So let's say that you're not happy with the fact that, let's say that the most stable figure, geometric figure is a triangle. You're not just happy with the fact that it's a triangle. So you start asking a question, why is the triangle such an important geometric figure? So you do some background research is step number 2, and it's a very important one because if we fail to investigate what humanity or society already knows, then we're repeating studies that might have already been done. So we know that there's studies that link height and weight, right? And we put those two together and that gives us BMI, right? If we failed to recall that, then we would start looking at that height and weight and linking them together again, and it's just kind of a circle. And so what's the purpose if we don't to do research and stuff? And that's why it's very important to write down our findings and to publicate them. So going back to the triangle thing, you want to see why it's such an important geometric figure, the strengths of it, right? And then you want to construct a hypothesis. So if you thought that a triangle isn't the most stable geometric figure out there, then you could make a hypothesis otherwise, right? You could say that a hexagon is more stable than a triangle. So then you have your hypothesis that a hexagon is more stable than a triangle. Then we got to test this out. So how would you go about testing hexagons versus triangles? Well, you would use those geometric figures to make a support or something and put weight on top to see which one buckles under the weight of what it's supporting and stuff. So you tested it with an experiment and you have what you have found, right? And so now you can make a more legit hypothesis about this. And if this hypothesis is true, just like we said, well, I'm sorry, let's say that the initial hypothesis is that triangles are not the most stable geometric figure. And then our legitimate one is that we found that possibly a hexagon was more stable geometric figure. So our final constructive hypothesis here would be that hexagons are more stable than triangles. So if this is true, then we would go ahead and report the results. If this is false or partially true, then maybe we need to go back and reconstruct our hypothesis. Okay, so sometimes you kind of have to start over again because what you found is not that important to stuff, to the findings, or it's just not true at all, right? Maybe you started out a research question and you thought you wanted to find something, but in finding that one result, you found that something else came up and was more important. So you went back and changed your whole focus to study that thing that was possibly more important than you originally thought. Okay, so we're going to take a pause here and I'm going to create a second video so you can watch that one right after this one. So sit tight.